Here we go. 4.5, the fundamental theorem of algebra. Our goals are to apply the fundamental theorem of algebra, to factor polynomials having complex zeros, and solving polynomial equations having complex solutions, okay? So, fundamental theorem of algebra basically stating that every polynomial of degree n will have roots counting both real and non-real roots up to their multiplicity, okay? We say polynomials has a degree where n is the largest exponent of x. So, for example, here I have this polynomial, and it's going to have a total of 5 zeros. We say a total of 5 zeros because they can be real or imaginary, complex, okay? Here again, even though there's no numbers present, I still can say that there's going to be a total of 3 zeros because my degree is a third degree, okay? The thing is that now we're not only just talking about our real zeros, we're now also talking about our imaginaries. Okay, so I'm gonna have to delete this. I forgot to delete all the writing off. We'll get there in a second. So if you look here at this function, we have negative x cubed plus 2x squared plus 2. Okay, we know that this is a third degree polynomial. Agree? Okay, we only can see one real solution. Because we only see one real, and this is a third degree, that means that the other two are non-real. Because together, they have to equal your degree. Okay, so what we don't see, we then have to say that those are our complex, our non-real, our imaginary. Does that make sense? Okay, all I did to find the value was I graphed it in my count plot to know exactly where it was at. But that's what we're going to be doing. Let me pause. All right, so now let's do another example. So here we have negative 2x squared plus 2x minus 3. Based on what we have here, what is the degree of this polynomial? It's a second degree polynomial, 2 degrees, right? All right, well, how many x-intercepts do it have? It has 0 x-intercepts. So that means that it has no real. Okay, however, that means that it has to have 2 imaginaries or non-real solutions. Does that make sense? Because it's still, these two need to equal that amount. Okay. All right. Let's try another one. What is the degree of this polynomial? It's a 4th degree poly. Okay. How many times does it cross? How many x-intercepts does it have? It has 0 x-intercepts, which means it has 0 real solutions, right? Real. So therefore, I have 4 imaginaries. Does that make sense? Okay. That's all that's saying. All right. Now, find a polynomial of degree 3 with the leading coefficient -3 and zeros 4, 2i, and -2i. Okay. So what happens here is that your I lets us know that these are our imaginaries, correct? And so we're looking for degree 3. I need to have 3 zeros combined in total. Do I have 3 zeros? 1, 2, 3. Yes, check. Degree 3. It tells you my leading coefficient. My leading coefficient is my A. So now I can write it in factored form. So in factored form, we have f of x equals, what is our leading coefficient? -3. Our first zero is at +4. So what is its factor based on the factor theorem? X minus 4. Okay, this rule still applies to imaginaries. If my first imaginary is 2i, then its factor is x minus 2i. My second factor is -2i, so its factor is. Okay, fun fact. Zeros, imaginary zeros come in pairs. They're going to automatically come in pairs of 2s. So if I know one, then I know the other. So if it only said I had 2i, I knew that -2i had to be there because Imaginaries come in. I always think I'm spelling this word wrong. Imaginaries come in pairs.
So on like the homework, will we put it as -3 x minus 4 2x minus I?
You're right.
Or will we keep it as 2I?
You keep it as 2I.
Okay.
Okay, so how do we feel about writing it in factored form? Doable? Okay, now it wants us to be expanded. Expanded means to get rid of the i's. So where you don't see the i's. And the way we expand is you're going to distribute and FOIL. Okay, so we're going to do distribution, distribute, and we're going to FOIL. So I'm going to highlight. I'm going to distribute with these two first. And I'm going to FOIL with these two. Does that make sense? Okay. So distributing, I have now -3x plus 12. Now I'm going to FOIL. So I have x times x is x squared. X times 2i is 2ix. -2 times x is -2ix. And -2i times +2i is going to give me -4i squared. Okay, this brings up some very important things for us to talk about. Whenever you have a I squared equals -1. Okay, anytime you see I squared, you're going to replace it with -1. So when we simplify this, it becomes x squared. What happens to the middle? They cancel out. -4, I squared became a positive 4. So now I have x squared plus 4 times -3x plus 12. So we distribute and FOIL. Now we're going to FOIL some more. Okay, I'm going to model the box method here if you're not a FOILer. Okay, so FOIL isn't your friend. For the second go around, I'm going to model doing the box. The beauty about the box is it works with whatever you have. So with the box, you're going to put your factors on the outside, -3x and 12, +x squared and 4. And you're filling in the box. -3x times x squared is -3x cubed. -3x times 4 is -12x. 12 times x squared is 12x squared. 12 times 4 is 48. A lot of times, if you are a visual learner, the box works better than FOIL. And whichever one you want, by all means, please do. I just want to make sure you know that you're capable of doing either one. So now that you have finished and filled in the box, your answer is all of your factors, all of your products in order of power. So my largest power is -3x cubed, followed by +12x squared, followed by -12x, followed by 48. And that is my expanded form. Okay, does seeing it in the box format work better than seeing it in FOIL? Okay. Especially if you're a visual person. Sometimes the box just helps you stay a little more organized. Okay, FYI, the box also works when you're doing your imaginaries. So for the imaginaries, you could have written it using the box as well. You would have had x -2i, x +2i, x times x is x squared, x times -2i is -2ix, x times +2i is +2ix, and 2i times -2i is -4i. These would cancel out, and this would become from a negative to a positive. So if the box works better for you, do the box. It also is just a good organizational tool. Okay. So if you want a bunch of boxes everywhere, no one's gonna know. It's your paper. All right. How do we feel about working with imaginary zeros so far? Doable? Okay. All right. Now we're gonna go back. Well, we're gonna undo it. So here, we were given our zeros and we had to find the factors and then we had to write the product, the full thing. This time we have to find the zeros and write the factored form. All right, this is a nice one because anytime I see 4, I should think, greatest common factor. Is there a GCF that can lead to this first? Okay. This is also kind of like a reverse box, so I can model it really quick with the reverse box, if that helps. It's a reverse box because instead of having the outside, you now have your inside. And you're asking, how did I do this? To do this, all you're doing is finding the greatest common factors around the outside of the box. So the GCF here is x squared. Do we see that? The GCF here is 9. The GCF here is x. The GCF here is -1. If the outer box is negative, your GCF is negative. So this in factored form is x minus 1 times x squared plus 9. Just like a reverse box. Does anyone want to see it with the grouping method? Are we all okay with reverse box? We're all good? Nobody wants to see grouping? It's where you pair them up and then find the GCFs. I can do it. I want to make sure that I'm matching and meeting everyone. So grouping, I pair them and then I find their GCFs. So the GCF here is x squared. The GCF here is 9. When you're finding the GCF, you're removing it. And then what is your common? X minus 1. You take out x minus 1. What are you left with? X squared plus 9. Do I still result in the same thing as doing the reverse box? So either one. Yay, nay? Okay. Now, once we have that, can I easily find my zeros now? Yeah, how do I find the zeros? Set them equal to 0. So x minus 1 equals 0 and x squared plus 9 equals 0. So my first 0 is 1. My second 0, I have x squared equals -9. I take the square root of that. And that gives me x equals plus or minus 3i. Because when you take the square, because I had a negative. So when you have a negative underneath the square root, that's how you create your I. So because it was a -9, it now has an imaginary attached to it. Because normally before, could we take the square root of -9? We'd be like, nope, no real solution, and keep it pushing, right? Well, now we know and express that this is a imaginary solution. So it's plus or minus 3i. Okay, so we factored, found all of our zeros. The problem, whatever it asked me, is completely done and good to go. No questions for real?
So we don't need, sorry, we don't need to write it as x minus 1 and then x plus or minus 3i.
Unless it asks you to.
Okay.
So if it wants you to go past this, then the next factored form would be like the factored with the imaginaries would be your x minus 1, x plus 3i, x minus 3i. So if it doesn't take this, then they want it in fully factored. But it just is, oh, I didn't read the word complete. Yeah, we did. Thank you, Andrew. I just saw factored form, my selective reading at its greatest. Okay, so this is factored, but not fully. This is factored. This is fully factored. So in 4.4, this is where you would have stopped. So this is stopping in 4.4. This is stopping in 4.5. Great question. All right, any other questions about example 3? All right, so gonna test you out here. Your turn on your own. Okay, so I'm telling you that you are a cubic polynomial. Your leading coefficient is -2. And the zeros that I'm giving you are 1 and 2i. Completely factor and expand. So if your reference would be example number 2, so if you need a reference, go back to example number 2 and see what we did there. And I made a comment about your imaginaries. They automatically come in a what? They automatically come in a pair. So even if I only give you one, you know that the other is always the opposite. There you go. All right, go. Okay, so this should have been your setup. And based on like kind of where we are as a class, I'm gonna assume that we are a box class, not a FOIL class. Yes. Is that a safe assumption? All right, so still we're gonna distribute. So the first thing we're gonna do is distribute. So we have our our complete factored form. Remember that for all imaginaries, they come in a pair, okay? So if I have x minus 2i, I have to have x plus 2i because they come as a set, okay? Now we're going to distribute and multiply. So I'm going to distribute and I get -2x plus 2 because a negative times a negative makes a positive. For here, if you're more comfortable than distributing, you're going to box. So I'm going to draw my little box real quick. I have x minus 2i. I tried to be nice and give you problems that numbers we already did, so that, but good practice, right? X times x is x squared. X times 2ix is 2ix. X times -2i is -2ix. And -2 times 2i is going to be -4i squared. From my box, these cancel out because one is negative and the other is positive. So I'm left with x squared. I squared equals -1. So whatever it's being multiplied by, it's going to change its sign. So instead of a -4, it's a positive. So that's one box down. Now we have another box to do. So my second box is now -2x and +2, x squared and +4. -2x times x squared is
backwards, like, okay.
Does not matter where it goes on the outside. Nope. 2 times x squared is going to be -2x times 4 is, and 2 times 4 is 8. My box is completed, which means I am done multiplying. Okay. My solution is just going to be in order of the powers. So it equals
2x.
cubed. Yep.
I mean, 2x squared
There you go.
plus 8. Or minus 8.
And then plus 8. And that is my,
I actually got it.
good job,
No problem.
my expanded form. Okay. So sometimes we just need to be able to see it spaced out. And that's what the boxes allow you to do, is see everything compartmentalized. Okay. Yes. Feel better about it? Cool. All right.
We're doing this too.
We don't have time. We're gonna pick this one up. We're not gonna have enough time to do this whole problem.
Oh, God.
Oh no. If you want to have it written down for Monday, you can.
Okay.